All right, welcome back to Fortran Bootcamp Part 3. We have here with us again our illustrious students, Jeremy and Spencer. I'll make a quick note right at the beginning of this video. I had someone reach out to me on GitHub saying that we had our file extensions wrong, that F95 wasn't the right file extension to use. I've heard a lot of different opinions on it. I need to dig into it more. I'll have more on that for you in a subsequent video. So hang tight, we'll learn more. But for now, we're just going to stick with the F95 extensions. Anyway, today we are going to talk about, I think they're called constructs, if statements and whatnot. What on earth? Oh, it would help if I actually opened it with, you know, a code editor or something like that. Okay, so we're going to start a program. We're going to call this program main just for the fun of it. Get in the habit of the first thing you do is comments, okay? Okay, so we're going to talk about the different constructs. There are a few different ones. There's if-else statements. We've got loops for dealing with arrays and doing other operations. And then we've got the select case statement, which Python doesn't have and which is really useful. It's kind of like, what does C++ has? C++ has switch. Yeah, I think that's what it's called in C++. Anyway, we'll go over that. First, we'll just talk real quick about if-else statements. So we're going to create a logical variable here up at the top. And I'm going to call it happy. And down here I'm going to say happy is true. And then we can create an if statement where we say if. So the syntax is if. Your conditional statement always goes inside of parentheses. So if happy, then we're going to do write. So we're just going to write out to the terminal. I am happy. Hold on, we'll get to that. And if, okay. A quick note here. You'll notice that my text editor is putting in tabs for me. The Pythonists among you will recognize that, or know that, white space is syntax in Python. You have to have tabs. Your tabs tell you, what your scope is, where your constructs begin and end. That is not the case in Fortran.
Might just make it easier to look at, though.
Yes, yes. So Fortran could not care less about white space, which is wonderful. I cannot tell you how many times I've been annoyed at Python for getting someone else's code where their editor was set to put in tabs and my editor was set to put in 4 spaces, and Python just flips out about it. It's the worst thing ever. Anyway, Fortran couldn't care less. Programmers care though. So this is maybe me. If you look at old Fortran code, they don't tab it at all, and I think it's horrendous to read. So I recommend tabbing your code just to make it easy to read. Again, the compiler doesn't care. Anyway, let's
so you could write it on one line if you felt like it. Or do entries matter?
It depends, but a lot you can do on one line.
Okay.
And we can fiddle with that in just a second.
Okay.
We're going to compile constructs, and then we'll just run a.out. I am happy, okay? Obviously, if we set this to false, then it will not print that out. Now we can add in an if or an else statement, and we can write sad. So now if we recompile it, the program's letting us know it is sad. Now we could put in another logical, we'll call this excited. And we'll put that true. And if, say, I want to say, okay, if you're not happy, well, are you excited? You can do else if. So you don't smash them together like in Python. You type it out. So else if. Again, you put your conditional statement inside of the parentheses. We'll put an excited. Then excited, else I am sad. Okay. Compile that. See, now the program is excited. This statement in here can be anything as long as it amounts, or as long as the result is a Boolean. So you could have this be dot and excited. Or, you know, it could be the return from a function, it could be a whole string of Boolean operations, as long as what it gets to in the end is some Boolean value. Now there are sometimes when this is all you want. You just have a single if, there's no else or anything, and you can condense this by just putting it all on one line. If happy, write I am happy. This is, you don't need the end if. And it's not printing anything else out, or it's not printing anything out because we told it happy is false. So that's one place where you don't need to end your construct. If it's just on one line, then you don't need to worry about that. I think you can still put in, no, I think it'll get mad at you for that. Yeah, so you don't put in an end if on that line. When we get to do loops, let's look at whether or not we can do that with a do loop. Okay, I think that's it with if-else statements. Questions?
That's pretty similar.
Yeah.
Okay.
Or actually, if you have an if statement and that is true, and then the else if is also true, will it only do the if?
Yes.
Okay.
It
Yes.
goes through and does it sequentially, just like in
Mhm.
Python.
Yeah,
So
because in
once it triggers the f or the if, then it's not going to do anything else.
It kicks out.
yeah, it's like it's as if you did. It's almost as if you did this.
Else, if, gotcha.
Yeah, so it's whatever whatever evaluates to true here, it's just gonna skip the rest.
Gotcha. Okay.
So, I don't know of any way to like handle multiple true conditions.
Right through it
You
through
just-
the loop, right?
I don't know if you do it with the loop. You'd probably just have to do multiple if statements without the else.
Right, yeah.
So, okay, let's look at loops. So to work on a loop, let's have an array. Have an array of reals. Did we talk about allocatable arrays last time?
Yes.
Okay, I thought so. We'll have an allocatable array, and then we're going to need to declare an index variable. Index variable is always integers. We'll just call it I. So let's initialize the array. My array. We'll declare some size up here. Say I want an array that's 10 elements long, so I'll make it size n. I could have left that as a lowercase n. Again,
Right.
Fortran doesn't care about case, but I like to keep it consistent. There's a lot of things that Fortran doesn't care about, but programmers do, kind of like the indenting we talked about. So be nice to your programmers as well as to your compiler. And then we're going to loop through the array, and let's say we want to set each element of the array, we just want to count up. We can do I equals 1 to n, and do, and we'll say my array I is equal to I. Okay? So this is the syntax for the do loop. You tell it what your index variable is, and then you say it's equal to start, stop, and then you can also put in a step. You can tell it to go by steps of 2, steps of 3.
Does it count from 0 or from 1?
So Fortran doesn't care. As far as this loop is concerned, it's going to start at 1 and it's going to go to n. And unlike Python, this is end inclusive. So if n is 10, it will go I equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will include the last value, which I like. Now by default, and we'll talk about this in just a second, by default my array is now 1-based indexing. So the first element of my array is element 1. Okay? Let's just, whoops.
And so, hence my array I
Uh-huh.
is, that's going to start with the first thing, which is index 1.
Yes. If this were Python, and we had zero-based indexing, we have to do an I minus 1.
Right.
This is not Python. Seriously. I'll try not to be too disparaging of Python during these videos. I don't know how well I'll do. Okay. Ta-da! And we can print out at each step of the loop what index we're at.
I have an off-topic question a little bit.
Okay.
So I was looking at some Fortran syntax stuff, and I found that you can do print statements.
Yes.
So what's the advantage of doing the double asterisk write statement versus a print statement?
I don't actually know.
Okay.
To be honest, I've never used the print statement in Fortran.
Okay.
So, yeah. maybe I'm missing the wonderful world of print statements, but write has worked just fine for me.
Okay.
That's a good question, though.
So, in your code there, you identified I as an integer. Right? So, you said that I was an integer,
Uh-huh.
but in there, when it prints it out, it's printing it out as a real.
Why?
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 But why?
Spencer,
Wait,
look at the code. Code can tell you why.
is it because you're putting it into an array that it makes it real?
What is the array? Look at the array declaration.
Oh, it's
Mm.
made up of real things.
Yeah, real.
It is a real array. So this is saying I want an array of floating point numbers. And so when you come in here to this assignment statement, the compiler knows, hey, this array is made up of floating point numbers. You need to cast this integer I into a floating point before we can store it in the array. So
Yeah, okay, that's fine.
I could change that, and I could make this an integer array.
And then it'll print out as integers.
And now we'll print
Okay.
out. Now we have an array of integers.
Makes sense. Cool.
Yeah, type declarations, man. They're what's up. Okay, now I wanted to talk about, that's what we were going to talk about. Like I said, Fortran by default is one-based indexing, but that is by default. The really cool thing about Fortran is you can do whatever you want. So I could declare my array, and I could say, I want you to start at 0 and go to 9. And now I would put in -1 here and recompile this.
It'll do the same thing.
And it does the same thing. But what this is saying is that, hey, compiler, when you put together this array, I want the first index of this array to be 0. And I want the last index to be 9. So by default, Fortran is one-based indexing, but again, you can make it whatever you want. I could put in -5 and 4 here, and this should give me. So you'll notice we're getting some unexpected behavior here because all of these elements down here have not been initialized. The first index I'm setting in this array
Yeah.
is index 0, And so index -5, -4, -3, -2, and -1 are not being touched. Like I said earlier, this is not terribly useful. I've used it once, but the one time I've needed to use it, it has been very useful. So just keep it in mind. It's one of those nice flexibilities to Fortran that let you do some relatively complex things rather elegantly without a whole bunch of, hoopla about it. Okay, so that's do loops. You can also we'll get rid of that. I'll just show you guys the step. So we could also do, I want to go from n to 1, and I could put in my step as -1. And now you can see in this loop, it's counting down. It's still setting the array in the same order because we're indexing elements of the array. The array doesn't care what order the elements are set in. We could also do this in steps of 2, and it will skip every other element of this array.
And starting from the end.
Starting from the end, yeah. Now we can deal with, I just want to go over arrays a little bit since we're talking about do loops. We can deal with multi-dimensional arrays. So I've added 2 colons here in the dimension declaration. So now I'm saying I want a 2-dimensional array, and in this allocate statement, I'll just put in n comma n to say I want an n by n matrix. Arrays don't have to be square. That's just what I'm doing right now. And then I can do a nested for loop, j1 to n. And let's write out both indices here. And we'll say that my array I comma j is equal to I times j.
So
Yeah.
you made a multiplication table.
We made a multiplication table. Hey! That's what you call that. I was trying to think of what that matrix is called, but yes, that's a multiplication table. And you can see here it's going through, and these are my I indices over here on the left, and these are my j indices over here on the right. Now, like we talked about in the last video, if we wanted to be efficient with Fortran memory, the way Fortran accesses memory, then we would switch the order of this do loop so that we're going through the i's faster than we're going through the j's.
Gotcha.
And that's again to do with those cache misses that we were
Because
talking
you're
about last time.
wanting to go by columns, not necessarily by rows.
Yeah, yeah. And so this order that you see over here in my terminal, this is the order in which the array is actually stored in memory. And so if we follow this order, we will be more efficient with our memory access. And if I were to come in here and make n be 10,000, we could time it and we could see the difference.
So you, yeah. J and then I.
Yeah.
There would be a difference in the timing of it.
Oh yeah. I mean, we might even be able to, here, let's see. Let's do something complex, square root of the log of, square root of the absolute value of the log of I times j. That should use up a fair amount of resources. We'll go up to 1 million elements. Okay, so this is with doing it the intelligent way. Must be real or complex. Okay, it's getting mad at me because I times j is an integer and it's asking me to cast it explicitly. There we go. Cannot allocate memory. Allocation would exceed memory limit. Okay, well, we're not going to go that big. Let's try dropping down a couple orders of magnitude. 3, 4, 5. Oh, hold on a second. There's a Linux command for timing some execution, isn't there?
I would have to look at
I don't know, 1, 2. Okay, so that took about 2 seconds. If we were to do now I, j,
that. It should be the longer way.
this should be the longer way. 1, 2. Oh, it's about the same.
Huh.
So in this case, didn't make much of a difference, but it can make a difference in a lot of instances. So a good habit.
Especially calling it. Or I guess the difference would be made in trying to access all of it, right?
Yeah. So, okay, that's it as far as do loops. You can also do while loops. So let's say I is equal to 0 here. I would want to do while, and then while, like an if statement, just takes a logical expression. And we say, well, I is less than n, we'll do I is equal to I plus 1, and we'll print out that index. Oh, wow, I forgot we set n to be still 10,000. Anyway, so you can see it's indexing I, and then at every iteration of the loop, it's checking this conditional. That's all a while loop is.
And it checks it at the beginning.
It checks it at the beginning, yes. C++ has it where you can do while loops where it checks at the beginning or the end. I don't know if Fortran has it where you can check at the end. I don't think it does. I've never come across that. What if you do need to check at the end? What you can do, I forgot that's what we're going to talk about as well. You can just say do while true, create an endless loop, and then here say if I is greater than or equal to n, then you want to exit. So exit tells it break out of this loop.
Could you also
Does the same thing.
set a variable that is true and then you redefine it as false and then it will break out?
Yeah,
Kinda
yeah, you can do that as well. There's let's see. You can, so this is, I mentioned this in one of the previous videos, you can name loops. So I can call this my loop. And this is really handy when you've got nested loops and you're trying to break out of one or the other of them. If you're trying to control loop iterations and you've got nested loops, it's best to name your loops. Because then you can say, you know what, let's create a nested loop. Actually, let me just show you this. So if I want to be explicit here and say, I want you to break out of my loop, then you can type exit my loop. And it knows for sure, hey, this is the loop that we're wanting to break out of. Okay? That's all it does. You can also, the exit command will break out of a loop. There's also a command called cycle, which will send you to the next iteration. So we can say, maybe we don't want to print out every single time, so we can say if if mod I100 equals 0, that's just saying if the remainder of dividing I by 100 is 0, then we're going to print out I, else, then I could call cycle my loop, and then write, I didn't. So what a cycle is telling is saying, hey, if you get to here, skip everything else in the loop and go to the next iteration. So if we pull this up, we run that. So every 100th iteration, it's giving me the index, and then because it didn't hit this cycle command, it's coming down here and says, hey, I didn't cycle. That makes sense? So exit and cycle are the same as in Python. You have break and continue are the keywords for that. Anyway, exit and cycle are very useful. I use them quite a lot.
So you could use that as you're looping through and you're dealing with like discontinuities and functions, and you don't want to divide by 0, for example. Then you could skip over things like that so you don't break your code.
Yeah. If you discover early on in the loop that subsequent calculations aren't going to work, then you could set some default calculation, then tell it cycle, and it'll just skip all of those.
Right. Yeah.
It's nice because, I mean, there's ways to handle it just with like if else, but then you've got, you know, this whole block of code sitting inside of an else statement. It's nice to just have a single statement saying, well, if this is true, then just go ahead and cycle it, and then do the rest. Do the rest otherwise, I guess. I'll show you, so again, it's nice to be able to have named loops because you can control which loop you're breaking out of. So if I have 2 loops here, and I'll control the first one with J, and doing this with, you know, integer indices is kind of mundane, you know, this kind of thing you might as well do with a do loop. But obviously this is just a simple example that I'm trying to get the point across with. So, so if I've got two loops here, and on my first loop I'm indexing j every time, then let's say I come in here and let's make this a little smaller. Let's do n equals 10. So inside of my inner loop, I still want this. I don't want it to run more than n times, so I'll tell it to exit my loop. And then I'll come here and I'll say in this loop, if j is greater than or equal to n, then exit my first loop. And we can be compact with this syntax here. I'll use that like we talked about previously. Okay, so this will run each one of these loops 10 times, so we'll get 100 iterations between the two. And of course, it won't actually do anything. Yeah. Well, that's interesting. Now, why is it doing that? So it's gone through and it's incremented I a whole bunch of times, and then it's incrementing both I and j. Oh!
It's only incrementing j in the first loop.
Well, and it's also not resetting I. So now every single time when we come into my loop, I is already greater than n, and it's telling it to exit. So we could come in here and we could say, then I is equal to 0. Okay, so that's saying if you've gotten to above n, then reset I, and let's run it again. Okay. But let's say I get to some special condition in here where I say if I times j is equal to, I don't know, 35, then I could say exit my first loop. And this should only go up until I is equal to, what, 7 and j is equal to 5? There we go. So from this inner loop, I've controlled the outer loop by having both loops named, and I can use their names to control them.
If you didn't specify which loop you want to exit, would it just exit all of them?
It will exit, I think, the
one you're in.
I think it will exit kind of the first one that you're in. Let's see what it does. Yeah, so it went back and it kept running my first loop, but we can see here at some point,
7 and 5.
yeah, at 7 and 5, it's gone and moved on to the next iteration of the loop. And then when we get to 5 and 7, it's moved on to the next iteration of the outer loop.
Good.
Which it's doing some kind of funky stuff because it didn't bother resetting I in the middle of that.
Right, so now it's like offset.
Yeah. So if you tell it exit or if you tell it cycle, it'll just do that on the loop that you're in.
Okay.
But if you name your loops, then you have control over which loops it does, which is really nice to have.
Cool.
Yeah, really cool. Okay. Let's talk real quick about just the select case statement, and then we'll be done. So say I've got some integer, and I'm going to call that option. And up here I'm going to set my option is equal to 1. And now depending on what option is set, I want to print out different things. Say option is 1, I want to print out you ordered a hamburger. I don't know, something like that. I can do a select case statement where I say, okay, the thing I want to select off of is option, and then I'll come in here and I'll put in the word case, and I say, and case 1, and I'll put right, and let me get this on, let me get me this down and I'll explain what it's doing.
Java has this.
Does it?
Yeah.
It's pretty common in languages. Python doesn't have it, which I think is dumb, but, you know, again, sorry, I'm trying not to be disparaging of Python.
Corn dog.
Oh yeah.
The most important dog.
It is. Okay, so what this is doing is this is saying within this construct, this is the variable that we are selecting things based on, and these are the different cases. So if option is equal to 1, then come in here and execute what's contained within this case 1 statement. If option is 2, then come and do what's in this case 2 statement. So if we run this right now, since option is 1, it should print out hamburger. We can change that to 3, and it'll print out corn dog. Now, if we were to do 8, there's not an option for that, and so it's going to do some or it's not going to do anything in this case, but you want to make sure you handle that, and you do that using the default case. So case default, you say, we can just say, well, if they didn't pick a valid option, we'll just tell them pizza. Not an option. No. We don't reward indecision here. So I'll just tell us that's not an option. Sometimes one of these will just be your default. So say I want hamburger to say I want hamburger to be my default. Then rather than doing case 1 here, I could just make hamburger be case default and not include 1 for 1. That way, if option is 1, it'll just execute that hamburger statement. Okay? Questions?
So what you would usually handle in Python with just setting variables and doing an if statement and then a print statement, you can do with this case option syntax, and maybe makes it a little easier to keep track of. Because I think in codes I've written in Python, some of the time I'm like, okay, where do I access that number that I was referring to? Is that kind of what the purpose is of this?
Yeah, and you can, the nice thing about it is you don't have to write, if I were to do this using if-else statements, I'd be doing if option equals 1, else if option equals 2,
Right,
else if
yeah.
option equals 3.
Yeah.
Which aside from being laborious to write and kind of annoying to read, that also takes up more computing power, because if you think about the structure of the if-else statement, it's going to go through and check every single one of those
Every time.
until it's true. Whereas this one, it's just going to say, okay, I know what option is, I know which one I'm looking for, and it's just going to go match it. So it's more efficient for running through a whole bunch of different options like that. Okay?
Cool.
All right. I think that'll be it for this video. Thanks for watching.